In this video, we're looking at locus. Locus is a set of points which satisfies a given requirement. So locus could be a line, a curve, or a shaded region, and so on. Now let's look at an example. We're asked to sketch the locus which satisfies modulus of z equal to 4. So what is modulus of z? Modulus of z is the distance of z from the origin. Okay, so we're looking for complex numbers which are 4 units away from the origin. Okay, so intuitively we can figure out there's one here on the x-axis, another one on the x-axis, similarly one on the y and another one up there on the y. And if we extend this, we know it's going to form a circle, okay, with origin 0, 0 as the center and radius as 4. Okay, so this is the locus which satisfies modulus of z equal to 4. So if we look at it algebraically, so we have z, let's say it's x plus iy, then modulus of z is x squared plus y squared under root. And we want this to be equal to 4. So if we square both sides, we get x squared plus y squared equal to 16. So what we have here is the formula for a circle. Okay, so the origin is the center, and radius is 4. Okay, so you can remember this, and this will help you in sketching loci in the future, where if you have an equation x squared plus y squared equal to r squared, so center will be 0, 0, and radius will be r. In this example, we're looking at locus which satisfies the constraint modulus of z less than 3. So now let's start with what is the equation going to be. Let's look at it algebraically. So let's say z is x plus iy, then modulus of z is x squared plus y squared square root, and we're looking for that to be less than 3. So if we square both sides, we have x squared plus y squared less than 9. So just like the last example, it is going to be a circle. The center will be at the origin. The radius, however, is 3. So let's start looking at that. A circle, whoops, with our center as the origin. Okay, so here we are. Now, you will note that it says less than 9. So we're looking at all the complex numbers that have modulus less than 9. So it is all of them inside this region. So we are going to shade the inside. Now, you'll notice the circle is not a solid line, and that's because it says less than, and it doesn't include the points on the circle, but only on the inside. So in this example, we're finding the locus which satisfies z, a modulus of z minus 1 minus I equal to 4. So let's start algebraically. Again, z is x plus iy. So if I write this out, I'm trying to sketch the locus which satisfies x plus iy minus 1 minus I equal to 4. So let's first combine the real parts together and the imaginary parts together. So I've got x minus 1, and then I've got, just taking out the common factor of I, y minus 1 I. Okay, and I'm just writing out the right-hand side, equal to 4. So we're looking at the modulus of this complex number. So it's going to be x minus 1 squared plus y minus 1 squared under root equal to 4. So squaring both sides, I have x minus 1 whole squared plus y minus 1 whole squared equal to 16. Now it looks fairly similar to the circle equation, except there's a bit of translation for our x and y. So the radius is 4, okay, so the radius is square root of the right-hand side. So we know the radius is going to be 4. Now, the only difference is the origin is not, I'm sorry, the center is not going to be at the origin. The center will have moved. Okay, so because it's -1, it will have moved 1 unit to the right. Okay, so 1 right. And here again, it's -1, so it will have moved 1 up. Okay, so it's kind of in the opposite direction. If it's -1, it's going to go to the positive direction for the x, and if it's y -1, it's going up. So our center for this circle is 1, 1. Okay, so let's plot the center. Okay, and the radius is 4, so 1, 2, 3, 4, and do the same. Okay, now just draw your circle, and this is the locus that fits that requirement. So in this, we're sketching the locus which satisfies the arc of z is pi/4. So what is arc of z? It is the angle, the line joining the origin and the complex number makes with the x-axis. So we're looking at a line along here, and that angle there is pi/4. So we have to make sure that we put a little gap at the origin. It starts after the origin, not at the origin. So we'll just put in a little, oops, it's quite, I'm going to make my pen a little finer to draw it in for you to be able to see it. Okay, there we are. Now, so this is the locus. Now let's look at it algebraically. So what is arc of z algebraically, or how do we work it out? It is tan inverse of the imaginary part of z over the real part of z. Okay, so it's tan inverse of y over x. All right, so we have arc of z is y over, sorry, oops, is equal to pi over 4, and it's equal to tan inverse of y over x. Okay, so we can just rearrange the equation. So this is our equation here. We've got tan of pi over 4 equal to y over x. So tan pi over 4 is 1. So 1 equals y over x, and x equals y. And we just have to be careful that we mention that x has to be greater than 0. So our equation is x minus y equal to 0, x greater than 0. So finding the locus which satisfies z minus 1 minus I equal to modulus of z minus 2. So first off, let's write what z is. Z is x plus iy. And then we are going to write this out in algebraic form. So we've got, oops, apologies. Okay, so we have modulus of x plus iy minus 1 minus I equal to modulus of x plus iy minus 2. So we know modulus is the distance from the origin to the complex number. First, let's write it out in more simpler terms on the left-hand side. So that's x minus 1, that's our real part. I'm going to take out the common factor of I, so I've got y minus 1 I. And then on the right-hand side, it's going to be x minus 2 plus iy. So the modulus of the left-hand side is going to be x minus 1 whole squared plus y minus 1 whole squared under root. And on the right-hand side, it will be x minus 2 whole squared plus y squared under root. Now, squaring both sides, we'll have x minus 1 whole squared plus y minus 1 whole squared equal to x minus 2 whole squared plus y squared. Now let's expand and simplify. X squared minus 2y plus, minus 2x plus 1 plus y squared minus 2y plus 1 is equal to x squared minus 4x plus 4 plus y squared. Now we can simplify this and we will have the x squareds cancel out and the y squareds also cancel out. And let's move everything else over to the left hand side. So we will have minus 2x plus 4x minus 2y plus 2 minus 4 to 0. Now if we simplify this, we have 2x minus 2y minus 2 equal to 0. So this is the equation that satisfies the constraint that is given to us. So there we have it.